Hi, you are watching another video of TM1, which is by Bharati DW Consultancy Services. Recently, I have received multiple requests to share my experiences on the TM1 project implementation. Now, this project is designed based on my experiences over the last several years. Please feel free to contact me on the following details if you have any questions regarding this project. I will try to keep this project at a very practical level. We will not discuss any kind of theory things, and we want to make sure that people understand the practical implementation from a project perspective. So here we go. Let's understand the business scenario for this project. So imagine Bharati DW Consultancy Services (BDCS) trying to implement a TM1 project for its budgeting, planning and forecasting needs. So this company is budgeting based on the actuals data for the past couple of years, and then it compares the current market situation and it decides its own budget. Initially, for budgeting, they set the lower expected target and also the higher expected target, where we call it as the worst case scenario, which is the lower expected target, and the best case scenario is the highest expected target based on the current market situation. We call the worst case scenario as minimum budget and the best case scenario as maximum budget, and let's look at the details of the budgeting a bit later. Our requirement is to get both the data sets, the actual data set coming in from the transactional systems, from a database, from a DAT file, from any sources, and the budget data is captured in a CSV or an Excel file which has the minimum budget and the maximum budget in one single cube. This would help the BDCS to budget its current year effectively based on the actuals of last 2 years and minimum and maximum budgets. It will come up with another version of the budget, would be finalized version or final version, and then this final version will be rolled out to the entire company as the budget to go ahead with. So let's see how to implement this particular case. First, let's understand the actuals data. So the actual data is available for last 2 years in a database, which can be a fact table in a data warehouse which is implemented, or it can be anything, a DAT file, any source of data. But for this example, we'll consider that the actuals data is available in a database in a fact table from a data warehousing world, the BI world. The actual data is available at the following granularity. We have customer ID at product ID for a date, sales type and sales status. So this data is available at customer wise, product wise, daily. It's a date level data, the sales type and sales status. And let's take a look at the facts available. Facts which are available are unit cost, unit price and quantity. So let's take a look at the database. This is the database which gives me the actuals data. This is the fact table F sales, and it has customer ID, product, date, date of procurement. Forget about this. We don't want to consider date procured. Sales type ID, which is domestic or international. Order status is either 1 or 2, which means active or inactive. We have sales status, which is again active, inactive. Unit cost, unit price, and quantity. Let's take a look at the customer dimension. The customer dimension is at the lowest level of customer, having name as an attribute, city, country. Customer type, it can be gold, silver, or bronze, and we have customer date of birth. For the product dimension, we have product ID, product code, name, product type, and product category. The sales type could be of two elements, domestic or international. So this is back again on the facts. I repeat: customer, product, date, sales type, customer sales status, unit cost, unit price, and quantity. So customer, product, date, sales type, sales status, unit cost, unit price, and quantity. Now let's understand the budget data. As we discussed, BDCS uses the actuals data from the transactional systems for last couple of years, and it's the basis for its budgeting. So the budget is done at two versions: the minimum budget and the maximum budget. The minimum budget is the worst case scenario, and the maximum budget is the most aggressive, the best case, the optimistic version of the budget. So the budget data is loaded from a CSV file, and let's look at the granularity of the budget. We have the budget as customer type, product, month, sales type, customer city, and budget type. So let's look at the granularity of actuals. The actual was customer ID, but here it is at customer type, which is different. Product ID is same as the actuals, product ID for actuals and product ID for budget. The budgeting is done at a monthly level, but the actuals is available at a date level. Again, the difference of granularity. And then we have sale type. Here we have sale type. This is fine, but also there is another level of customer city, which is at the budget, but the sales is at the customer ID level, the actuals, which takes care of the city and customer type. Let's look at it in our examples, how we take care of this difference of granularity. And the facts are available at unit cost, unit price, and quantity. Facts here available are unit cost, unit price, and quantity. So we are good on facts, but let's understand that the budget data is different grain with actuals, because we capture the actuals at the lowest level, which is customer ID, product ID, and the sale type and the date. But for the budgeting, we cannot budget for a date. No company does that. So we do the budgeting mostly at month level, the customer type, what type of customers we do our sales for, and the customer city. So let's take a look at the budget data. So this is the budget data: month, budget type, minimum or maximum budget, the customer type, customer city, product, code, sale type, unit cost, and unit price. This is budget, and it is coming from a CSV file, not the database. Let's do a design. So we are now into design phase of the project. We have understood the requirements. So from a solution perspective, we do require a cube with a combination of actual and budget data sets. This is our first. So please note that the budget data is available at a higher granularity than actuals data, obviously, because we don't do the budgeting at the date level, we do the actuals at date. Therefore, we need to create a cube which is having the common granularity between the budget and actuals. That means in this case it will be the budget granularity which is available, which means that we need to roll up or aggregate the actuals data to match the granularity for budget. From a solution perspective, we propose to add a field which will be record type dimension, which will be similar to the budget type dimension having max budget and min budget. But along with this max and minimum budget, we also have actuals as a record, which indicates that it's the actual data which is coming in from the transactional systems. So the actuals would be tagged. The row which comes from the actuals database fact table would be stamped as record type as dimension, and record type would have the following possible values. Then we will have the minimum budget, which is the budget type minimum, and the maximum budget, which will have maximum budget type. So the final budget or the finalized budget would be having final underscore budget as record type, which would denote the budget which is between the mixed minimum budget and the maximum budget based on the decisions taken by the managers, right, for that company. So based on our understanding till now, we propose a cube of the following granularity. We'll have customer type, product ID, month, sales type, customer city, and there will be a new record type which would be having these four values as we discussed. Please note that this is mostly the granularity coming in from the budget data with the addition of the record type as a new change. The facts would remain same. The facts have unit cost, unit price, and quantity. The other part of our solution would be to create a cube which will be entirely dedicated to the actuals data only, no budget, just the actuals data, and then we'll have the following granularity. So this is the granularity which is coming in directly from the fact table of the database, which is actuals granularity. And so as a summary of this solution, first we understood the requirements. The requirement was to have a budgeting facility for Bharati DW Consultancy Services, BDCS, so that it can do the budgeting with actuals in mind, with a minimum achievable target based on the worst case scenario of the current market situation, the maximum most aggressive target, the max budget, and then we'll have the final budget. So from a technical design perspective, we will have two cubes, one cube which will be having actuals and budget data together with the granularity as budget, and then we'll have second cube number only for actuals data, which will have granularity at the same level as fact. So if you need the data for practice, the database which I have is Microsoft Access database. You can use Oracle, you can use DB2, you can use any database. If you need the budget file which I am going to use in my exercises, you can just email me or contact me on the number given above. So let's implement that. Let's implement this requirement with a proper design, and let's see how we come up with a solution. This is a very high level design. As we go on, we will do the low level design at cube level. We will do the scheduling and refresh of the cubes. We will also do security, so we don't want anybody to change the data. We just have few specified set of people who can set the data or delete the data, modify the data. We'll create a lot of turbo integrator processes to load dimensions, to update the cube. Let's see how to do it. So please wait for the next series of videos which will implement this design. Thank you. Have a great day.